Question 2 of our tutorial is about something quite similar to the same scenario. Let's go through the question and see. So the ABC Engineering is a piling contractor where they are considering the purchase of two different piling machines for their next project. The first option is a board piling machine with an estimated cost of $10,000. Based on the contractor's history of risk taking and competitiveness for the project, it's been estimated that the machine has a 25% chance of breaking the drill bit and a 75% chance of not having breakdowns. That means being successful. Since the project is scheduled in a rainy season, there's a risk of the project running late to complete. The client has specified that there will be a penalty for each calendar day. With previous project experience and taking into account the late penalties, if the contractor goes ahead with the board piling machine, it has a 25% chance of earning 250,000, a 40% chance of earning 150,000, a 20% chance of earning 80,000, a 5% chance of breaking even, and a 10% chance of losing 20,000. The repairing cost for the drill bit off-board piling machine would be 5,000, and the time taken for the repair is negligible compared to the project's duration. And we have some more information about the second type of piling machine, which is a CFA as well. Right, so some of the things that we need to identify is that now there is a repairing cost as well, but it doesn't say after repairing the drill bit what are the resultant values are. So we may have to assume it's gonna be the same, right? A repetition, because it also mentions that the time taken for the repair is negligible anyway. Right, so I hope you will be able to generate this the decision tree, and I will be using the one I have developed already without spending all time on the same thing as we did for the previous question. So we have two options, two decisions to make, board piling or CFA. The respective costs are there, and a 75% successful operation percentage, 25% machine breakdown, 65% for CFA, and 35% for the CFA breaking down. And these are the outcomes, and we have another decision. So when the drill bit is broken, then we have the option of repairing or abandoning. If we abandon, there would not be any income attracted, just the expenditure. But if we repair it, then we are assuming that it's pretty much the same that we are earning from these two um, activities. So when you develop this the decision tree, you may have done this or not have done this. So we have this option of copying an entire tree, entire node, a tree after a node in precision tree. So it's quite simple. Just right click this particular node and copy the subtree. Just select this, right? And when you come here, just right click it and click the paste subtree. Okay, and it would replicate the same thing, exactly the same thing over here as well. So it will save you a lot of time, I suppose. Right, okay, so we have the decision tree, and now it's about identifying what the best decision to go ahead, or just looking at the facts and figures. So you may realize now, for the previous question we had a fairly a small straightforward tree, but when we have a lot of inputs and outputs, our decision tree would become quite large and finds not too difficult but still may not be clear straight away. So for that, we have the option of generating a policy suggestion. So when we go to the decision analysis, this is one option given by the precision tree. When you go to the decision analysis tab, the button, you have the option of developing a policy suggestion. Just click on it, and then we have the option. So the model, yes, the model which we are looking at is the same thing, and we have the option of selecting the starting node. So either you can select the entire model, or if there's one particular event, so let's assume the machine background, you can select that as well, right? The decision with respect to the cell which it's located. So I'll be selecting the entire model for this instance, and I will tick the optimal decision tree box. So what I need to see is the optimal decision tree. Then click OK. This will generate the policy suggestion tree. So you may see that the true nodes are there. The true nodes are there. So what this suggests us is, if we are to decide a piling machine, to select a CFA, right? And in case the machine breaks down, it also suggests us to repair the machine. So the benefit will be or the income would be the maximum, right? So if we decide to leave or abandon the machine after the breakdown, it won't generate enough profit for us. So that's what the policy suggestion tool is there for. This is one handy tool when we have larger decision trees, because it's quite easy for us to lose focus and make it complicated for us to identify clearly what's the best option provided from the analysis. And the other important factor is the risk profile. So you can develop a risk profile for this as well. So let's just select the entire model and select all the results, right? Okay, so this is a histogram. So what this assumes is, because we have discrete functions, we don't have the probability functions, or the probability distribution functions. We have a discrete values or discrete distributions. Because of that particular reason, we have a discrete table sort of a thing. There's no variation, but it's the numbers. But what this says is, now looking at the values, the CFA will be giving us the maximum benefit, right? The maximum profitability, uh, even though the cost is quite high, right? And the board piling wouldn't give us enough profit, and it would give us the lowest profit as well. So it also gives us the cumulative chart or the S curve. This is quite handy when it comes to comparing these two. So it's quite obvious as soon as you look at this, uh, which piling machine we should look for. It also gives a statistical summary if we are to use these particular values in a report or somewhere, right? And then the other option we have through the precision tree is the sensitivity analysis. So what does this sensitivity analysis means is, now what would happen if there is a change of these particular values, right? So we are assuming CFA to be 8,000 right now, but what would it be if it changed drastically? Okay. uh, yeah, so let's have a look at the sensitivity. So we have the one-way or two-way sensitivities, but for the time being, well, let's just stick into the one-way sensitivity. And I'll just delete these two and add another thing. So we are selecting the starting node would be the entire model, right? And we need inputs now, inputs to decide. So let's select the CFA, right? Just select the CFA's value. Okay, you have the option of having this particular value somewhere else and referring to the node that particular box, so it will be more clear when it comes to the sensitivity analysis. But let's just go ahead with the defaults and have this, right? Okay, uh, and we can also have another value. We can have the board piling as well. Right, click OK. Okay, so we have two values now. Sensitivity. Let's just look at the results. Right, so B46 refers to the CFA. We can see what's the variation or the expected value, the variation of the expected value if there is a change of the cost. So we had 8,000, right, as the cost, but what would it be if we have a 10,000? What if the CFA is 10,000? Then what would be our expected value? And if it is 6,000, what would be our return or the expected value, right? So, and when it comes to B6, so what the B6 says is, although even though it varies from 10,000 to 7,000 or 1,300, the expected value wouldn't change significantly, right? This is because of the fact that um, the governing factor for this particular tree is the CFA machine or the CFA piling. So this governs the analysis. So that's why, although uh, the value of the board piling machine changes, there won't be a difference in the expected value. So that also suggests that even though there's a higher difference between up to 1,300, there won't be an selecting the board piling would not be the best way or the go ahead. So this is the difference in strategy. You can see why it's not being affected. So basically the difference between these two strategies, the values, it's almost 7,000, right? So only if that particular amount comes into place, there won't be a big difference. So it'll always be like this. So there's a huge difference of the expected value. So that's why it's not being affected. There may be other instances where you may have a smaller variation in between. So there you may able to see that the sensitivity, when the value changes, the decision could shift or change to the other one. The tornado graph says that what's the governing um, factor in this particular decision tree we are looking at. So it's obviously the CFA node, right? And the board piling node doesn't really appear in this the tornado graph, right? Um, yeah, even the spider graph says now we are at 0 right now, and the blue color demarcates the CFA and the red color demarcates the board piling, right? So the unless the change of input, if it comes to uh, uh, 3%, the expected value would be uh, uh, then the board piling would be preferable if there's a 3% change of input, right? But beyond that, if there's a positive 30%, then of course it will be the CFA. Okay, so these are some outputs or some metadata that helps us to uh, decide what the best strategy for our decision making process. Right, so that brings the end of the decision tree tutorial. Decision tree. Um, I would suggest you to use few examples available. You can use the precision tree, just use the help, and there's a lot of videos and also example spreadsheets, right? So there's basically a video for every example spreadsheet. So if you go to example spreadsheets, there's a lot of spreadsheets available, from basic simple ones to more detailed ones, right? So I strongly encourage you to go through these things as well and watch the videos as well. There's enough videos available online by Palisade. So they would be solving all these the examples given here. So it would give you a better understanding of how to use or to use these tools, right? But for our purpose, knowing the decision tree, how to build a decision tree and how to do the analysis should be adequate. So we will be ending here, right? And yeah, so I hope these set of videos will be helpful for you for understanding what the decision tree is. And you can send us your queries through email or in live sessions so that we can have a discussion after you gain some experience, right? Thank you very much.